Assalamualaikum warahmatullahi taala wabarakatuh. So my name is Muhammad Armin Hakimy bin Muhammad Nasharudin, AN 190077, and my supervisor is IRTS Muhammad Hairi bin Osman. So today I want to present about my final year project 1, and the title is Bonding Behavior of Steel and Concrete containing palm oil fuel ash, POFA, and containing expanded polystyrene, EPS. For table of content, first is introduction, second one is literature review, third one is methodology, fourth one is conclusion, and the last one list of reference. For the introductions, wastes from industries and post-consumer items such as expanded polystyrene used for packaging are non-biodegradable, yet are often disposed of by incineration or disposal in landfill, resulting to environmental contaminations. In order to reduce the danger of environmental contaminations, lightweight concrete can be produced by using expanded polystyrene. POFA is restricted and unmanageable, yet its quantity rises every year and the vast majority of it is discarded and producing environmental and other problems. Numerous studies have demonstrated that POFA containing concrete has greater compressive strength, durability, and other qualities than OPC that have only concrete. Other studies have demonstrated further benefits of POFA substitution in concrete in particular quantities, including the reduction of CO2 gas emissions and consequent improvement of environmental conditions. For the objective for this final year project, the first one is to determine bonding strength between EPS, POFA, concrete and steel by using rebar pull-out test. The second one is to find the ideal replacement material percentage of POFA and EPS. And the last one is to investigate the mechanical of concrete containing POFA and EPS. Scope of study. Due to the fact that the physical and mechanical characteristics of expanded polystyrenes EPS are distinct from those of traditional fine aggregates, the study focuses on the use of EPS as an addition in concrete while holding the other components, which is sands and granites, constant. Numerous research has been undertaken to determine the value of palm oil waste applications in the production of concrete, and it has been determined that these wastes have value. So the bonding strength of steel and concrete will be determined using 10% of palm oil fuel ash, POFA, and expanded polystyrenes. Several tests, including the compression cube test, the pull-out test, and the diffraction test (XRD), were undertaken. Total of 48 test specimens for each replacement percentage has been used. For the literature review, first is concrete, that consists of Portland cement, water, and aggregates. And we have 9 grades of concrete for a specific purpose. For this project, we use grade 25. And for POFA, palm oil fuel ash, POFA is an industrial byproduct of the palm oil industry. It is produced by the combustion of palm oil plant byproducts. POFA has been utilized not only in conventional concrete but also in specialty concrete such as high strength, high performance, and aerated concrete. The EPS was composed of 98% air and 2% polystyrene substance. It is impervious to water adsorption and has excellent impact resistance. As a result of its durability and thermal insulation capabilities, EPS is commonly employed in the packaging industries. The pull-out test, which involves pulling a reinforcing bar from a concrete block, is the most common method for measuring the bond strength between reinforcing bar and concrete. Effective adhesion between reinforcing bar and concrete is required for the full development of composite action in reinforced concrete. Consequently, the connection of reinforcing bar is essential to the structural behavior of reinforced concrete. For the flowchart, after we identify the problems, we do some literature review, and after that, we have some material selections, and the material is cement that we use OPC, and EPS, POFA, fine aggregate, and coarse aggregate. For the specimen preparation, we use a total of 48 specimens for this project. And the next one is laboratory testing. There are 3 tests that we run. The first one is compression cube test. The second one is pull out test, and the third one is SRD, which is X-ray diffraction test for POFA identification. The next one is data collections, and the last one is data analysis. The conclusions: the application of EPS to produce lightweight concrete can simultaneously mitigate the consumption of natural aggregates and polystyrene waste generation. Rich in SiO2, thus POFA acts as a good pozzolanic material to replace cement in concrete mixings. In terms of compressive strength, the concrete sample made from cement and the POFA with original cell have less compressive strength than conventional concrete samples, but the concrete samples made from cement and POFA with fine particles have compressive strength higher than traditional concrete samples. From environmental perspective, agriculture waste material have been investigated by many researchers and have been shown that to have a better properties in concrete than the cement materials, whereas the latter also generates a high amount of CO2, which is harmful for environment. The last part is list of references. So this is the sum of my references that I use to guide me to complete my thesis. I think that's all for my presentations. Thank you.